we are happy to launch our new product, which is called aquaVIEW, which is responsible for monitoring water bodies, water spread area, irrigation tanks, and wetlands. So the beauty is this all happens in autonomous fashion and enables everybody, whether a community manager, manager, conservation authorities, or department authorities who are responsible for irrigation, to do all these activity completely anonymously. So it doesn't involve any human interaction. Everything happens in very automated fashion. We'll talk about more in coming slides. So let's start with our agenda. So we will be doing a basic introduction and for initial 5 minutes. Then we have our guest of honor today, Dr. Shiv Mohan sir, who has been in this industry from a long time. I will introduce them. I will introduce him, and then we will talk about how industry is adopting such kind of solution. Then I will have Saptarshi Mandal, Dr. Saptarshi Mandal, our remote sensing expert, who will be presenting the solution, and then we will understand how this solution is going to impact the market, what kind of adoptions can happen, and at end we will have QA around us. We will start. I will introduce our guest of honor, Dr. Shiv Mohan sir, who has been a leading researcher and educator with a specialization in microwave remote sensing of Earth and lunar surfaces. He served ISRO during 1978 to 2011 and initiated microwave remote sensing application program. He was principal investigator of many prestigious projects on microwave remote sensing, which were awarded to him by ESA, JAXA, NASA, DLR, and Italian Space Agency. His research contribution resulted into development of an in-house application program for ISRO, like Joint Experiment Program, where he worked as project director. He was the main architect of India's first RISAT utilization program, where he worked on project director until 2011. He was lead contributor of Chandrayaan 1 Minisar water ice detection model and in the definition of Chandrayaan 2 SAR payload. After retiring from ISRO, he worked with Planet's program of Physical Research Laboratory, where he evolved application of dual frequency microwave data for lunar water ice model, regolith depth modeling, and crater morphology. He had served more than 70 technical committees of ISRO involving microwave remote sensing activities, including RISAT, Chandrayaan 2, and future Venus mission. He was visiting scientist at German Research Organization during 1980 and 1981 and chief scientist HARSAC Haryana government during 1998 to 2001. He has more than 320 research papers in journals, conferences, ISRO reports, and conducted about 190 tutorials on microwave remote sensing in various national and international programs. This has just been a very brief introduction to him, but we can't, explain more on that because his legacy is still continuing and he is actively participating in this domain of microwave and remote sensing data for benefit of the society and overall how this technology can adopt it. And he is participating with various of agencies and government programs to understand how these things can welfare the society at a large scale. So, Dr. Shiv Mohan sir, I would like to invite you to introduce us on this technology, how these are useful, and what kind of adoption can happen in the domain of water bodies and wetland monitoring.
Okay, thank you, Amit Mishra, for a nice introduction. And certainly, it is a movement close to our heart, those who initiated remote sensing in our country. In fact, the lead of those periods, they are seeing that the technology, what we were evolving and what we were pursuing at various level, I mean to say government departments and the user level, we have to create users also in early remote sensing days and a little tough time. But today I am seeing with the availability of a large number of satellites with different ability, different resolution, and different repeat cycle, many of the things which were not possible in earlier time are becoming possible, and one is able to have a better kind of management of various resources of the country as well as about the globe. We can talk of both level and at a sitting on your desktop or laptop, one can manage many of these things. So certainly it's a happy moment for me to see that development is taking place in the private sector, corporate sector, that technology is being now taken from the government department where we were working mainly for government requirement, but there are many applications which can be handled by these industries, space industries, and the application are being evolved slowly for the country, and the country is also getting ready for giving a lot of concessions to startups and those who are working in this field in an efficient manner. So certainly a great moment for me, and also I have feeling that the present environment allows us to see the water resources not only from optical but the micro also. There's a great contribution from European space agencies who are giving us free data set in the micro, which was earlier very costly and very demanding kind of data set. So with this kind of free data and with the technology, what country has grown in terms of IT sector, both combined together is able to give a platform which uh, is developed as a aquaview platform by uh, this company. So I feel honored to be here, and I will certainly happy to see the how development has taken place in the company. And obviously it's not a single use of the data. There are a lot of challenges when you do a technology and you bring to a level where operationally any decision maker can make use of it. So I congratulate the team, and I congratulate all of you, those who are involved in development of aquaView. And certainly we will see next 1 hour the process, how you have gone and what you have achieved. So thank you, Amit, for this. Few more, uh, few more things that uh,
Sure, sir.
the development in the micro are rather difficult, which you have handled it, because there are a lot of issues in concern to how a water body behaves, and especially when it comes to accuracy, then interface between the land and water surface. So the algorithm as well as models and also deep learning approaches have helped certainly you, and I think accuracies are certainly much better than what one was doing a decade before. Okay, over to Amit.
Thank you, sir. Thanks a lot for your motivating words. And it's all with the guidance of industry veterans like you, which guides us to innovate and make a feasible product out of the research work and out of the academic work which you people produce. So I'm again feel honored to have you on the panel today. So now I will introduce you to Dr. Saptarshi Mandal, who is our remote sensing expert and who has been industry veteran. He has worked on various of national international projects and papers. He has did his PhD from BIT Mesra. He has been a PhD researcher on mountain agriculture projects, and he is instrumental in developing this product AquaView at Wasser Labs, and he has implemented that also to one of the state government that has been a pretty successful product, which we'll talk more as he drill downs to the presentation.
Thank you, Amitji, for your wonderful introduction. So it has been an interesting journey for our entire team involved during developing AquaView.
Thanks. So I will just start with the basic introduction of the company. Wait a minute. I think Saptarshi. Yeah. So thank you, Saptarshi, for acknowledging. I will start with the basic introduction. So let's start with our company first, because I believe a lot of people here are you know interacting with us for the first time. So we have started in 2014, and we are now 178 plus people. We are primarily working on sustainability domain, where our focus is to build solutions powered by AI and ML in the primary sectors like agriculture and water resources to ensure that we are moving towards sustainable future. And we are serving various of state government clients like government of Andhra Pradesh, Telangana, Odisha, Kerala, as well as we are working with national agencies like NHP, Niti Aayog, as well as international agencies like UNDP. Our work has been awarded at various forums, like we have got CBIP Best Consultancy Award in Water Sector 2020, AI Innovation Award by Niti Aayog for Agriculture in 2019, and we have various partnership with Google on various of research programs. So water bodies have been around us from a long time in form of wetlands, in form of rivers, in form of pond, and they are critical resource for the fresh water. And over the time, if we see in the last few decades, 50% of wetlands have been destroyed. That has been exclusively published by downtoearth.org, who has surveyed this and who have made an interactive video on that. And then the impact of these water bodies are multifold because they are responsible for recharging groundwater, having biodiversity in place, having a sustainable watersheds, as well as providing irrigation to the agriculture, which is very much important for our food. So we can see it's very much connected with us. And then surface water bodies are crucial in planning and management because they keep changing. They are dynamic in nature. And that's the primary purpose why we need to constantly monitor that. To have this, we have already built a platform called aquaVIEW, which has been implemented for various solutions in integrated water resource management and also in similar domains like flood forecasting and flow forecasting, operational uplift schemes. So we have leveraged the same platform because it helps us to get data from any source and then deploy AI ML algorithm by using cloud, and then gives us intelligence in form of geospatial insight as well as in form of smart dashboards, and then help us to take decisions by providing decision support system. On based of these platforms, we have built AquaView. AquaView, which helps you to understand the water body at one side. On the second side, helps you to understand the complete workflow and intervention strategy around that by viewing them in near real time. So from here onwards, I will hand over to Mr. Saptarshi to take us through the wonderful journey of AquaView. Thank you, Saptarshi. Over to you.
Thank you, Amiji. So aquaView is an integrated cloud platform that uses open source satellite data from Sentinel Hub and has been set up with machine learning model to monitor surface water bodies. The platform comes with very user-friendly GIS dashboard interface and mobile app which helps to visualize water body related analytics and historical trend charts. Next slide, please. Some of the key highlights of aquaView are it provides all-weather monitoring capability thanks to Sentinel-1 microwave data. Platform provides near real-time analysis using at every 5-day and 12-day interval. Platform provides time-to-time alert and advisory through SMS, through email, through mobile notifications. Platform is very useful in case of agriculture and irrigation planning. It's one of the best application is monitoring irrigation tank to track its water availability and to provide timely irrigation support to farmer. Platform is also useful for wetland conservation and urban lake protection monitoring. Salient feature of the aquaView platform. So right now platform is using freely available Sentinel-1 and Sentinel-2 data having 10 meter of spatial resolution, which provides capability to monitor water body or irrigation tank as small as 0.5 hectare of size with more than 90% accuracy. It also provides near real time as well as provides historical trend analysis of the water spread area, water storage, filling percentage in comparison to max water level. Platform also provides capable to provide some on-demand features like water body catchment analysis, cascade analysis, crop analysis within the IACAT area of the water body. Platform also comes with geo-intelligent mobile app through which we can deliver all the analytics, also helps to identify water bodies and verification of the water body related analysis. So as I said, entire processing and computation happens in the cloud machine through automatically without any manual intervention. We use Apache Storm task scheduler to check if any new data ingested in the Sentinel server every hour through downloader API. Once download is done, system starts sensor specific and internationally recommended pre-processing steps. For example, in case of Sentinel-1, we perform orbit file correction, and then border noise correction, thermal noise removal, radiometric calibration, speckle removal, and a trend correction, for example. Once processing is done, we convert the output BVVH data in case of Sentinel-1 into 3-band RGB, and then we use pre-trained machine learning model to detect water, and finally we use trapezoidal and DEM-based dynamic depth estimation method to compute water body-wise water storage and volume. So as Sentinel comes with two polarization band, VB and VH, and we often see these bands in a grayscale. So sometimes our data can be hard to interpret in the grayscale, but a transformed color visualization can help to focus on a specific aspect of the data or any feature-specific target detection. So also helps to generate images that might be used for further analysis. So with this purpose, by taking the inspiration from Sentinel Hub, we are transforming VVVH polarization into a 3-band RGB that helping us to visualize water in a blue color that's very easy to visualize within a large spatial extent and very catchy to eye. During the R&D phase, we have tested multiple ML and DL algorithm along with multiple model training strategy by using various data combination, and found that Sentinel-1 RGB is providing better water prediction quality compared to BVVH in terms of less noisy prediction and better edge detection in the water body. So system estimates water volume using DEM-based depth computation. After each satellite overpass, model extracts the corresponding DEM value using detected water spread for a water body and find max water level. And then it estimates water depth by subtracting max water level from each pixel value. And finally, volume is estimated by multiplying pixel area and the depth of all pixels, and then aggregate it to get the final volume information. So aquaVIEW platform has very interactive user experience. It allows user to have aggregated view as well as individual water body view with their various characteristics at the same screen. As you can see on the top left, there is a controller which allows to choose location, source, frequency of the data, or aggregation, and the date range. So once you select, then you can see in the top left, there is in the bottom, you can see layer control of multiple GIS layers. And also it has drawing feature. On the top, you can see GeoPortal zoom control. On the top right, you can see key performance indicator, which provides aggregated as well as individual water body level information like max capacity, current storage, water spread area, fill percentage, etc. And then you can see trend chart followed by universal search option to search water body or any admin units within the study area. So here you can see two results showing water spread and depth category at multiple timestamp. So on the left side, we are showing detected water spread in the timeline, and in the right side, same water spread is used, and along with them, we are converted into a depth category. So which gives a perception at which area, what kind of water depth is available, and at the edges or in which part water depth is low at different time level. System also providing a trend graph, and here you can see multiple trend graph from multiple water body. So top two charts showing multiple water peak during Kharif and Rabi season. The second peak during Rabi season may be due to water transfer or filling due to irrigation purpose. In the bottom two graph, you can see single water peak mainly during Kharif season, primarily attributed to rainfall, whereas during Rabi season, water body is gradually becoming dry and water level is coming down to zero level. User can add any water body boundary using the platform itself, doesn't require any technical skill. If you have shapefile, simply upload it Or if you want to draw polygon within around the water body, you can draw through interactive map on the screen using the inbuilt draw tool. Once drawing is completed, then next user can fill required attributes. So like tank name, maybe a unique GeoID using latitude and longitude. Then system will automatically fill the existing information, like in which area that water body falls, like which state, which district, which mandal. And then user can provide basin, sub-basin related information, and also user can give capacity, max capacity information if available. If not, we will collect system computes this inside using the DEM. System also comes with an integrated mobile application that has very intelligent capacity like geofencing. User can walk around the water body and it will draw the boundary automatically. Also comes with on-field picture capture mode, where we can verify the water level or water body status through pictures. It has also ability to view all the analytics trends, and also user can receive alerts through the mobile app. So system gives an understanding to analyze water body health, impact of conservation activity, readiness of the cropping season at the multiple administrative level, like state level or district level or mandal level. At the same time, as I said earlier, user can assess individual water body as well, along with the historical trends of volume and water spread area. So thank you. I'd like to hand over to Amit ji for the next part of the presentation.
Thank you, Saptarshi, for the wonderful illustration of the product. So now with that illustration, we conclude why it's important and what kind of value this system brings in. So first thing the system has is ease of use. So nobody requires to actually have any kind of geospatial or remote sensing skills. You just have to log in to the system and you can, like Saptarshi had shown you just now, it can be simply by drawing your water body or wetland on the map itself, or it can be uploaded via shape file. And just in matter of few clicks, the tracking starts. There's no interruption. Second, it's on cloud, so it's always on. So it's a new principle of new www. So whatever, wherever, whenever. So this is the all informations are accessible. The third part, it's cost effective. So now if you see most of these kind of solutions, if you see the implementation right now happening inside the government or at an institutional level, it requires you to have an infrastructure first. So it's a big expenditure basically to who have all these things. Now, what exactly we are doing here? So the input cost, first thing you have to understand, the input cost here is zero because we are using satellite data. Second, we are bringing it on a SaaS model, so you don't have to own any infrastructure. So the cost would be very minimal. It's like pay as you use. So you want to have, and the cost would be like per water body kind of thing. So you can start as low as possible, and then can scale. So for example, it can start from a village level, going to the block level, mandal level, district level, to the state level, to the country level. So that's kind of flexibility is there in this platform. The fourth part is mobility. Say, for example, if we talk about wetlands, if we talk about conservation sites, if we talk about a large scale of watershed, then it's not possible to have the analysis all the time. It's very resource extensive. Second, you have to understand where we want to have focus. So all these reports are seamlessly integrated in the mobile workflow. So everything is mobile in this particular application of AquaView, and it gives alerts and insight for the things which matter. Say, for example, which irrigation tanks or which wetland it's suffering a loss, either in terms of capacity, either in terms of encroachment. So you get alerted for those specific activities, and then complete workflow how to tackle that is embedded in the system. So there can be various value addition to the same tech stack, providing multiple use cases. Say, for example, if we talk about irrigation use case, that can start from understanding the historical pattern of the irrigation tank. So by understanding that with the historical 5-10 years of satellite data, We can create a benchmark saying how much it's depleting over the time. Is the health of water body remains same? Is the health of catchment itself which remains same? In case of a wetland, whether it's expanding, it's decreasing, what is the span over time, the percentage of decrease is happening. So those kind of things can be managed and monitored seamlessly inside the platform. So with that, now I thanks all the participants to listen about our product. Now we have experts here, Dr. Shivmohan sir, Dr. Saptarshi Mandal from the product side, Shivmohan sir from the industry side, and I will be here online from the product side. Let us start with your questions. Whatever you have, just put it on the chat box and we will answer that. So with that, now we conclude our presentations and we'll be moving towards Q&A sections. Meanwhile, by the time you will be entering your questions and thinking about it, I want to invite Dr. Shumohan sir to give us idea about what he feels about adaptability of such solutions in India or at international level, and what kind of potential use cases he sees. Shumohan sir, over to you.
Thank you, Amit. It's a wonderful platform which I never imagined that we have reached to that level unless we interact and we find that this is one of the key requirement as water is one of the key driver for our day-to-day life as well as for our ecosystem and environment. So certainly the application finds a way for many of the decision makers, whether it's a wetland manager or a district administrator or a land use expert, because water body keep on shrinking or increasing in size, and volume which you have added into this tool is one of the important which adds the value this to the irrigation requirement of any catchment area or and again it's for drought monitoring wherever there is a requirement of many water tank, it serves the purpose. So basically what I am seeing, one can do many things on the ground using ground sensors, but the importance is the managers. A secretary, he can see the overall status in his room itself. On his laptop itself, he can see what is the status of water. Before he gets a report from ground line officers, he is able to see everything on. So it's a better managing system, and this is the beginning of managing our resources through a virtual platform, which is, I think it could be the first where the resource manager or the district administrator, they would be using a tool sitting in their lab and in a, of course, virtual environment. And I am really happy to see this as one of the development which has taken place, which has come out from the industry. In fact, government sector, we work slightly differently. So it's real kind of user requirement which satisfies, so you interact with all users, and private users, ISRO and other government organizations are not able to support fully because they have their different commitment. So it is a unique tool and it's a timely tool. Timely in the sense it is a country is looking for privatization of space sector in terms of satellite and also application. So it's very timely, and getting this to be inaugurated or and this period is really great. And I think it's a first tool which I am seeing, which a manager can see. Manager, I mean a district collector or a wetland manager or a water resource manager or a irrigation engineer or whatsoever different level, because this information you are able to provide at different magnitude of the projects or different scales and different resolutions. So it's very important that it covers a large segment of the society and the customer in terms of industry. Maybe UN customer and global expert will be looking for this kind of data. Of course, things are available at a global scale, but volume is still a missing component, which you have added. I'm really happy to see that volume part in your system. So I again congratulate you team and of the Vassar Lab itself who took the initiative. Not only initiative, but it is providing the employment to GRS, geoscience community in the country. And obviously we have a better, today we have a better set of people who could serve your company, and certainly we look for better product with the availability of better sensors in future. We are going to have RI set 1 which will be available, so you should be able to improve in terms of time information, which is generally 12 days. You can do repeat cycle 6 days or 8 days depending on how it is coming. Certainly with ISRO, you have NISAR, that is dual frequency SAR with a high resolution up to 6 meter. So you will be able to pick up very small size of water body, which are important for, you can say, the urban planners. They look for the permanent water bodies and how it is spreading. So I find it's a very timely and suitable platform which you are giving to the country itself. And I wish you, your team of Watson Lab, who initiated the product and delivered at a right moment. Thank you, Amit, and thank you, team.
So thank you, sir, for your valuable comments, and it's been really encouraging to understand from you how industry can adopt and what kind of right direction for such kind of product is there to be implemented. Now, moving toward the QA session, let's see. There are a couple of questions. I will start and I will assign it to our panel expert. The first, it's from Dr. D.S. Bist, scientist, NIH. So the question is, well, first, it's congratulations. Thank you, Dr. Bist, for congratulating us on this product. And now the question is, how accurate are the depth estimates captured using water spread and DEM? So Saptarshi, Dr. Saptarshi, this question belongs to you. Please go ahead.
Yes, thank you, Amitji. So it's a very interesting question, definitely. So we have validated our results definitely with some of our field data, like government measures water body volume time to time during the uh, multiple assessment period. So we have cross-checked our estimation at the full water level, so that came up with at least more than 95% close to the assessment of the government.
Great. Thank you, Saptarshi, for the answer. So that's good. Now, moving to the next question, it's from Shalini Taluri, Senior System Analyst, Vadvani. So the question here is, what is the ML model used in this solution? How did you evaluate the accuracy of it? Saptarshi, why not you talk about some field experience where you have validated along with the model name?
Yes, so we have used here a random forest that is trained temporally. Basically, we have used wide range of temporal data to capture all the variation in the SAR data, basically in the water body, sometimes wind speed or ripples due to rainfall that affects the backscatter value. So that's why we included wide range of temporal data in the training part to recover that uncertainty. And the second part is the accuracy. So we did some field validation definitely time to time. Whenever satellite overpass happens, our field team went to field and measures the water level, and with the GPS tagged information, and with our analysis data, we cross-checked that information with our prediction results. And that is, if we claim it is more than 95% accurate.
So we have one more question. How ML-based water detection result in better compared to other conventional methods? What's your experience in?
So it has been a good, interesting R&D phase for us during development of this product. So we started with scientific algorithm. We investigated widely available literature internationally, and we tried multiple recommended method definitely before going to ML. So one of the basic one is the threshold based. We started with that, and we saw that due to inherent nature of the backscatter and the SAR data, that doesn't give you proper value pattern due to, like I said, wind speed can affect the backscatter value. It creates ripple in the water body, so can give higher backscatter. Also, rainfall, ripple due to rainfall, it also gives kind of higher backscatter. So any particular statistical model that was not fitting, and so then we came up with the, we started ML and trained it at very, temporal horizon, and then assess the prediction accuracy using the ground truth data. And finally, once we satisfied, then we went ahead with the deployment.
Good. Thank you, Saptarshi, for the answer. Then there is one more question from Amruta. Can a user edit any water body boundary if required? So yes, the answer is yes. User can edit it anytime, and the system creates a log of edits. So admin can see by when this last edit happened, and it can show the versions. So it logs the version history of all the edits, so that it records. So nobody can just enter, and this will not go unrecorded. So thank you for the question. Now we have one more question from Bharat Kumar uh, from NRSC. Most likely, DEM is generated based on scenes acquired once, twice in a year. Are all water bodies empty when data is captured? So, Saptarshi, why not you?
Yes, it's a very good question, definitely. Yes, so the DAM we are using is from European Space Agency. That's the very latest one using Pulsar. And yeah, so that is the data accuracy happened some time in the year and few years back. That's an uncertainty, of course, still is there. So to overcome this, of course, with the recent technology like drone and lidar survey, periodical survey can be done, and a system is capable to handle those kind of high resolution data, and we can give better estimate time to time.
Thank you, Saptarshi. So idea here is that yes, the question is true. When the DEM data is captured, there is a possibility that water body will not be empty that time. So there can be a chances of uncertainty in those kind of data, which needs to be corrected with the further set of validations. Next questions we have from Shakti Gonewar from Solution Manager HDFC Bank. Yeah, thank you for the illustration. And the question goes like, okay, it's from government bodies. Could you please further elaborate on the industry application of the solution? Yeah, that's an interesting thought on that. Yes, the industry adoption is also there for the solution. Now let's understand where this solution goes into. So the solution goes in three primary area. One, where we are trying to understand what is the health of water bodies in any region. So now if you see the health of the water bodies in any region, it gives you n number of things. Like say for example, it gives you understanding of crop. So if you are so like a bank, it's offering its credit solution to the farmers. They are offering crop insurance solutions. So there, this is a very vital input. So they know the how much irrigation in any rain-fed area or tank irrigated area has, what kind of potential it has. And the historical trends basically helps you understand that how it's happening. Is it declining in a trend or it's increasing? What is the productivity achieved over the time from that particular water bodies? So that's one commercial use case. The corporate engagement, or you can say the industry adoption, would be very much if you want to relate that with the yield data. Say, for example, if it's FPO, you wanted to invest in this. So FPO wanted to understand how much yield they can expect, and the yield will be directly proportionate to the irrigation potential of that particular region. So there will be few. Obviously, we will explore more on the commercial side of this, and probably your thoughts we will welcome, and we will sync on that to explore more on that. How well this understandable to a layman and how efficient the system is. This is from IIT Madras, Akanksha Soni. Okay, so for a layman, I'll try to explain this whole solution in 1 minute now as a concluding remark. So if you see this system, there are water bodies in remote places, there are wetland in remote places, and all these areas, if we see, it's difficult to monitor. So the idea what we are doing here that we are giving you a platform where you can say that this is my water body or wetland, as simple as it by pointing it out, and then the system automatically gives you data about how well it's performing, whether it's getting improved, whether it's degrading, and whether it's maintaining its status. So that's the solution it's all about. And based on this aggregate, it's about one tank. If you aggregate the tank, number of tanks comes for a district, for a state, for a village, for a block, then it helps you to understand the complete planning spectrum of agriculture and the water sustainability for that particular area, the health of watershed. Updating you with all our new product enhancement. The product roadmap looks like we will be improving this product from agriculture insights that will be come as add-on, where we can talk, understand about the cropping patterns, understand about the crop history, tank performance, efficiency. Then we are upgrading it to the to identification and workflow for the encroachment, for especially for the wetlands. And then we are also trying to have more and more accuracy, reaching more towards 100% as much as we can, This particular platform also supports commercial satellites to increasing the frequency or accuracy. But we wanted to achieve the same using the free satellite data to make sure the platforms is still feasible for all the stakeholders. And going forward, we will be doing our next webinar on land use intelligence system in month of March. We'll invite you for that, where we will be learning more on how this satellite data help us identify even a minute change in the land and understand how are the implications for that particular change, either in form of encroachment detection, either in form of identifying urbanization, urban growth, monitoring the linear construction growth, understanding our canals, rivers, our floodplains in more details, and understanding how these kind of tech enhancement and interventions can move us towards sustainability in future. Thank you once again for the participation. I am Amit Mishra along with Dr. Simohan sir and Dr. Saptarshi Mondal signing off for today. Thank you and have a
Thank
good
you.
day to all of you.